Let's talk a bit more about scalars. Scalars are more peculiar than higher dimension objects because they are single numbers. We didn't talk about it, but you know very well how to add two scalars together, right? 5 plus 5 equals 10. 10 minus 4 equals 6. No biggie. You also know that in order to add vectors and matrices together, their forms must match. We are not allowed to add vectors of different length and matrices with different dimensions. Such operations are not permitted in linear algebra, and Python knows that. For instance, if I try to add a 2 by 3 matrix with a 2 by 2 matrix, we will get this message. Operands could not be broadcast together with shapes, and we will be shown the operand's respective shapes. Similarly, if I try to add two vectors with different lengths, I will receive the same error. Mathematically, these operations don't make sense, so they cannot be executed. Okay, there is one exception. Because of how arrays work in Python and many other languages, we can actually add scalars to matrices and vectors. For instance, if I add 1 to the matrix M1, you can see that 1 was added element-wise. In other words, each element was increased by 1. Similarly, if I add 1 to the vector v1, it will be added element-wise. Mathematically, this operation is not allowed as the shapes are different, but in programming, or at least in Python, it works. Alright, it was very important to be aware of this peculiarity. Probably some of you may have already tried it and found out that it yields a result. The result has a meaning in terms of arrays, but not in terms of linear algebra. That is also one of the big differences between the concepts of ND arrays and tensors.